My name is Jarl Boyd. I'm a PhD student here at the Geological Museum of Copenhagen, and thus I am a geologist. I feel like I'm very curious. When I see something going on in nature, I want to know how it works. Want to know all the processes behind it. I don't just want to sort of enjoy it, I want to feel it.
Our society depends upon reliable information on the state of our natural resources, such as water, minerals, energy, and climate change. Geocenter Denmark is a joint cooperation of 4 research institutions, all working with the objective to monitor, explore, and provide advice on the current state of our natural resources in Denmark, the Arctic, and beyond. In a series of films, we meet the scientists behind Geocenter Denmark.
So my PhD is about the oldest rocks on Earth and what they tell us about early plate tectonics. There are different theories on when the continents were created, but the problem is that when you look at what the ages are of different parts of the continents, it doesn't add up to all of it being created very early on. So the thing is that we've lost a lot of the continents over time, and they've been recreated. But what is it about continents that make them stay? Why do some parts of the continents sort of stay stable for 3.8 gigayears, and other continents sort of get created and then recycled right away? And we don't really know how that happens. We don't really know why some continents are stabilized or how that happens. We know that some are more stable than others, but not really in detail. Every summer we go to Issua. Issua is a piece of oceanic crust which has been preserved since 3.8 billion years ago, and that's where I do all my field work. We take the plane from Copenhagen to Kangerlussuaq in Greenland. Next day you might take the helicopter up through the fjord, which is very beautiful. You get to fly past all the inaccessible rock faces, and you get to see all the geology of the area from the air, and also the ice sheets, and you get to see the fjord and how it interacts with the water. Then they land you down in Issua. We get out, we unload all our stuff, and then we put it in a pile, and then we sort of all keep it there as the helicopter it ascends, because the wind from the helicopter is very strong. Once it's left us, it's very tranquil out there. You can see history unfold, or at least a snapshot of it. So we ship the rocks back to Copenhagen, and once they're here, the first thing I do is I go down into the lab, and you start cutting rocks. You start cutting small pieces from them, and then you crush them up, first with a jaw crushing machine, and then in a rock mill that grinds it into a small powder. Then you need to analyze the powder for its elemental composition or its chemistry. Once I have the element extracted, I can measure its different isotopes using a mass spectrometer. And the isotopic signature of a rock is it's like a barcode. It's something that is unique for one component in the system. You get some data that you can work yourself backwards from. So you know some points, but you want to know how you got to those points. So you work backwards. You go back in time and say, how would rocks have to develop through time to give me the signatures that I have now? I hope to be able to say that plate tectonics started as a process quite early on Earth, and that when it started, the continents started being stabilized, and that Issua is an example of a new continent being stabilized.